all. In this video, we will learn about dot conventions. Students will be able to analyze the multi-winding inductor circuit. Convention. Since it is inconvenient to show the construction details of coils on a circuit schematic, we apply the dot conventions in circuit analysis. A dot is placed in the circuit at one end of each of the two magnetically coupled. Step to analyze the dot. Select a current direction in one coil and place a dot at the terminal where this current enters the winding, and determine the corresponding flux by application of the right-hand rule. The flux of the other winding according to Lenz's law opposes the first flux. Use the right-hand rule to find the natural current direction corresponding to the second flux. Now, place a dot at the terminal of the second winding where the natural current leaves the winding. Dot rule. When the assumed current both enters or both leaves a pair of coupled circuit by the dot terminal, the signs of the M term will be the same as the sign on the L term. If one current enters by a dotted terminal while the other leaves by a dotted terminal, the signs on the M terms will be opposite to the sign of the L term. Current entering from the same terminal, then we use the first equation, that is V1 of t is equal to L1 d by dt I1 of t plus M d by dt I2 of t, and V2 of t is equal to L2 d by dt I2 of t plus M d by dt I1 of t. And if both the current entering from opposite side or opposite terminal, then we use the second equation, that is V1 of t is equal to L1 d by dt I1 of t minus M d by dt I2 of t, and V2 of t is equal to L2 d by dt I2 of t minus M d by dt I1 of t. Series airing. In this connection, two coils are connected in series such that their induced fluxes or voltages are additive in nature. Here, current I1 and I2 is nothing but current I, which is entering dot for both the coils. Leading. Consider parallel coupling of two inductors as shown in the diagram. Apply Kirchhoff voltage law to both loops. We get minus j omega L1 I1 minus j omega M I2 plus V is equal to 0, and minus j omega L2 I2 minus j omega M I1 plus V is equal to 0. And then solving this equation for I1 and I2 yields I1 is equal to V into L2 minus M by j omega L1 L2 minus M square. Using Kirchhoff current law gives us the equation of I, and we get the simplification form of as L equivalent is equal to L1 L2 minus M square by L1 plus L2 minus 2M.